Question 22, generate parentheses from LeetCode. Let's jump to the question. Given n pairs of parentheses, write a function to generate all combinations of well-formed parentheses. So let's see what this question is asking us to do. The question is saying, so n pairs of parentheses are given, we should form all the well-formed combinations that are possible. So what does it mean? So a well-formed parenthesis is there is an open bracket and there is a closed bracket. If we have just open bracket or closed bracket, that's not a well form. So the well form is an open bracket and there is a closed bracket. So when it says n is pairs of parentheses, so it means when it's 3, it doesn't mean we have a 3 like open bracket or closed bracket. It means we have 3 pairs of parentheses. As you see, 3 pairs of parentheses, something like this, and like this, or something like this and this and this. These are all well-formed parentheses, and as you see, there is an open bracket and there is a closed bracket, right? So these are well-formed parentheses that you see. And if n is 1, so there is only one pair of parentheses, an open bracket and closed bracket. Let's jump to the solution and see how we can solve this problem. So we are going to use backtracking function for this problem. It's good to use backtracking for permutation or combination problems. And what we are going to do here, we are going to use an array to store all the combinations that we have, and this is what we are going to return at the end. For the backtracking function, what we are going to do, we are going to consider an empty string, and we are going to use left for open bracket and right for close bracket. And when it starts with 0, it means there is no open bracket and there is no close bracket. And we start adding to this one as we are adding open or close brackets to the string, to the combination that we are making. So we need to have a condition that with what condition we are going to end this function and add that combination made to the array. So this is the condition that we are going to use. We are going to say if the length of the string, the p string that we are making, is 2 plus n. And you might say, why 2 plus n? Because as I mentioned, we are talking about n is a well-formed pair of parentheses. So n is for every single n, we have an open and closed bracket. So when we are saying like, okay, if n is 1, we are talking about this. So it means we have 2 brackets. So this is the number of brackets that we are going to have. So if n is, for example, 3, we are going to have 6 brackets. If n is 2, we are going to have 4 brackets. So the length of the p string that we are making here is going to be including the open and closed brackets, which is n multiplied 2. So if the length of the string is equal to 2 multiply n, so it means we have made the combination of well-formed parentheses, which we can add it to the array and return, and this is where we return the to backtracking function. And we have 2 conditions here. So the first condition is for the open parentheses, and the second condition is for close parentheses. So what we are going to do here, we are going to compare the number of open parentheses to the length of n, to the n that is given to us, and for the close parentheses we are going to compare it to the left one, as we are saying for every open parenthesis there should be a close parenthesis. So what we are going to do, I'm going through this illustration, and so this way you can have a better understanding of this code. So what we have here, so we start the backtracking with an empty string, and we start with 0 open parentheses and 0 close parentheses. we call the backtracking function, and we check this if condition first here. We see, okay, this is empty, so this is going to be for n 3, the length is going to be 6, so 0 is not equal to 6, so we are going to check if 0 is smaller than n, which is 3, and it is. So what we are going to do, we are going to add an open parenthesis, and we are going to increase left to 1, right, as you see here. And then the function is called again, so it's a recursive function, so we are going all the way back here. We're going to check the length of this is going to be 1 is not equal to 6, so we are going to add another parenthesis, and l left is going to 1 is going to be added to the left. And then it's a recursive function. We're going to call the backtrack function again, and this time 2 is smaller than 3, so still we call this backtracking function, and 3 open parentheses are added here, and we call the backtrack function recursively again, and this time 3 is not smaller than 3. So now it's time for checking this if condition, which is for close parentheses. So it says if right, which is 0 now, is smaller than left, which is 3, and it is, so we are going to add a close parenthesis, and the same thing is going to happen. So 3 is not smaller than 3, so 2 is smaller than 3, we are going to add another close parenthesis and another close parenthesis, and as you see here, we have made our first well-formed combination here, which we can add it to the combination array. What we're going to do now, we are done with this, so we're gonna return the result, and we're gonna backtrack and go back to the function here, which we are going to called the backtrack function. And what we are going to do is going to get to here, from here it's going to get to here, and from here is going to get to here. So now we are going to see, okay, we have 2 open parentheses, we are done with this part, and we have backtracked to here. So now we are going to add a close parenthesis here, and the backtrack function is called again, so 2 is smaller than n, so it's gonna add an open parenthesis here, and it keeps calling the function recursively, and it's gonna make the second well-formed parenthesis, and then it's gonna backtrack again. As you see, it's gonna backtrack from here to here, and it's gonna make the third well-formed combination, and the fourth well-formed combination, and the fifth one, and then it's gonna return the combination as the result. So as you see here, the time complexity is going to be this, and the space complexity is going to be this, and this is the space complexity is because we are using backtracking and recursive function, and we have stacks. Thank you.